So we're going to talk today a little bit more about how to find absolute extrema on a closed interval. It looks like we've got a grand total of, 4 examples today? So it should be nice and short, hopefully. All right, where did it go? There it is. Okay, I'm going to go back. All right, so these are the steps that, or the guidelines for finding extrema on a closed interval. You might want to, I have a way that, or I wrote down a little bit extra on the side here, kind of the steps that I would take. We got to find the critical numbers. In order to find the critical numbers, we have to, so to find the critical numbers, remember the first thing you do is you take the derivative. Take the derivative, and then the second thing you do is you set it equal to what? 0. Set the derivative equal to 0. And then the other place you can find critical numbers is setting the denominator equal to 0. So set denominator equal to 0. So if there is a denominator, there isn't always a denominator. So then after we found the critical numbers, which is what we learned, the skill we learned yesterday, we're going to evaluate at the critical numbers and also evaluate at the endpoints. And notice, this is for finding on a closed interval, it's for finding the absolutes, okay? So there should be at least one that's a min, that is at least one that's the smallest value, and at least one that's the greatest, because we're working on a closed interval, not an open interval. All right, we good with that screen? Make sure we're good before I move on. All right, we're supposed to locate the absolute extrema of the function on the closed interval. So the first thing we're going to do is take the what? Derivative. Remember, we have to do calculus, right? And the calculus is a limit or a derivative at this point. So you've got to do some calculus. So what is the derivative of that function? Okay. And now to find the critical point, what do we have to do? Good. I'm going to let everybody catch up. He probably didn't write them down, so. But he knows what he's doing, so. He wasn't even listening. You probably didn't write your notes down.
Yeah, no.
See, he even admits to it that he didn't write them down.
I looked it at home.
Did you write it last year?
I actually did write it last year.
Oh, okay.
Hey, listen. I don't even forget my book last year. Last year I actually never forgot my book. It was always in my bag.
Oh.
But this year I tried to do homework, so like.
All right. Okay, what do I have to do from there? We're thinking algebra now. Set them equal to 0. Zero product property, right? Okay, so you guys, at some point you're going to just recognize that that's 0, isn't it? Yeah, so if you really need to go through the steps, you can, but, 0. So but you could just write it as 0. We're that far into calculus that if you could do it in your head, that's fine. Okay? So x equals what on this one? 1. Good. So I've got my 2 critical points now. Okay? What did it say that I'm supposed to do with those critical points? Evaluate. So I'm going to plug them into my original function. Okay? And you might want to write, so I'm going to look for the critical points into original, so critical points into original function. I wouldn't write that down in your homework. In your notes I would, right? So you understand what you're doing next. All right, so I'm going to evaluate for f of 0, and I'm going to evaluate for f of 1. Okay, so I'm plugging in a 0 into this. What would we get out of it when I plug in a 0? 0. Do I really need to write that work down where I show the step where I'm plugging the 0 in? Not really. No, not even for the AP test. They would just look for the 0. Okay? But the 1, I might do a little bit of work. What 1 to the 4th is 1 times 3 is 3. Minus what? 4, which gets us negative 1. Then it said we had to plug in the what? The endpoints, because the endpoints could also, sorry, I went the wrong way. The endpoints could also be a max or a min, and this only happens on absolutes when it's closed. Okay, and absolutes only happen on closed. So we're going to plug in endpoints. okay. Dumb questions are fine in here. We know that. And you probably aren't the only one thinking it. What happened to the exponents?
Yeah, but then I was like, oh, we did them, like, we used it.
Yeah, we're good. Okay. All right, so we're plugging in a -1. -1 to the 4th is what? 1 times 3 is 3. -1 cubed is? -1 times -4 is? +4, so it equals 7. So it is good to write a little bit down, especially early in the morning when our brains aren't quite awake yet. Okay? Plugging in the 2. 2 to the 4th is? 16. Good. 16 times 3 is? You all have calculators, right?
No, 54.
It should be 48, I believe. All right.
Wait, 6 times 3, you're right.
Okay. 2 cubed is? 8 times -4 is? Good. So what does this one turn out to be? 16. So now what you're going to do is we have to find the exact value of the max and the min, okay, for the absolute max and the absolute min. So you're going to look at these 4 numbers. Which one of those is the smallest? -1 is the smallest. So my absolute min is at 1, -1, and you're going to list the point. Notice, remember, the point, that's your x value, that's your y value. Sometimes they may write the point, and we've got to get used to this in here. F of 1 equals -1 is also a way to write a point. Okay? All right. Absolute max at, what's the biggest number? 16. So my point would be 2, 16. What goes into these x values here? So you put your critical points in, right, and your endpoints. Right, that's why I labeled it. These 2 are the critical points, these 2 are the endpoints. And then you compare all 4 of them, or however many of them there are. Okay? All right, let's try it again. A little bit different function. Okay? More room on that one? Okay, I'll write it down. I got to find that notebook, and I got to write it down yesterday. You needed more room on one of them, too. All right. Good morning. I figured you'd be on the field trip.
We leave at like 9:30.
At 9:30?
Country.
Oh, it's for cross. Oh, that's where they are this morning. Is cross country. Okay. Huh? Your sister made you get here early? She's not going on the cross country field trip, is she?
Did you not buy one?
I did.
Cross country.
Huh?
Cross country field trip. Cross country.
Cross country. I know me.
It's the same thing.
I used to go on those. They're going to Mount Sac today, right? Yeah, that was my favorite race.
Wait, tell her
Huh? I loved it. It was great. You
You
got the flat, the hill, the switchback. It was our favorite race of the year. Yeah.
Yeah. I'm gonna tell Terry to give go to meet.
I have like 4 of the shirts that have the cartoon on the back. We always had to buy the shirt. All right, let's do this one. Here we go. So the first step is doing the what? Derivative. Okay, let's get back to calculus. All right. So we're going to take the derivative. What's the derivative? 2x? 2. Okay, now let's think about this one. I've got to take this and move it to the front. So when I do 3 times 2/3, I get 2. So minus 2x to the, we're subtracting 3/3 off of that. Negative 1/3. Good. I'm going to rewrite that though. Okay, before I get my critical points. I'm going to rewrite that as the cubed root of x. Right? Because I'm bringing it downstairs for the negative, and then I'm rewriting that into a radical format. And I'm going to set that equal to what to get critical points? 0. Here's the problem. When I go to solve that, so I'm going to show you my work for solving it. I'm going to take this thing here and add it to the other side. So 2 over the cubed root of x. If I cross multiply, I might get some values off of this. I cross multiply it, so I get 2 cubed root of x equals 2, right? And then we divide by the 2. When I divide by 2, what do we get? 1. And then I cube both sides. When we cube the 1, what do we get? 1. All right, but there's another place to get a critical point. It had a denominator, right? I can also set that denominator equal to 0. All right, so when I set that denominator equal to 0, what's my other critical point? It's also 0. So the next thing I'm going to do is I'm going to check my critical points. Okay, so I'm going to put my critical points into the original function. So I'm going to put in the 0. I'm going to put in the 1. All right, putting in the 0. What? Okay, let me go back. He was trying to. There was a lot of noise. It was okay. All right, so do we understand? Where did I lose you at? Here?
Right there.
Right there? Okay, so I was looking for a critical point, right? So I moved this guy to the other side by adding. I cross-multiplied it, so that gave me the 2 cubed root of x. I divided by 2. That gave me the 1. And then I cubed both sides. I got a 1. Okay? And then the other place I can get a critical point is by setting the denominator equal to 0. So I set the cubed root of x equal to 0, cube both sides, got a 0. Everybody good? Yeah. Okay. So now we need to plug our critical points. And where do I plug the critical points into? The original function. Okay, so when we plug a 0 in, what are we going to get out of that? 0. Good. We plug a 1 in. What's 2 times 1? 2. What's 1 to the 2/3 power? No. 1. Think about that. So the 2/3 power is really saying the cubed root of 1 squared. What's 1 squared? 1. Cubed root of 1. Cubed root of 1. 1. So I really get, and no matter what I put a 1 into, I always get a 1 out of it, right? So 1 times -3 is, so my answer is, good. I put the critical points in, but there's something else we have to put in. What else do we have to put in? The endpoints. Okay, so I'm going to also plug in f of -1 and f of 3. This is going to be uglier. Okay. All right, so what is 2 times -1? -2. And then -1 to the 3 or to the 2/3 power. So let's think about what that really is. All right, 2/3 power is really the cubed root of -1 squared, isn't it? We talked about that here. So what's -1 squared? 1. What's the cubed root of 1? 1. So really, don't I have -2 minus 3, which equals -5. Good. It wasn't as bad as it seemed. The next one's going to be a little bit uglier. All right, so because I ended up going to a decimal point last year. All right, so 2 times 3 is what? 6. Minus 3 times 3 to the 2/3 power. There is no good way that that's going to happen, right? 3 squared is 9, and we can't take the cubed root of 9 nicely. So here's what you're going to do. You're going to put it in your calculator just the way it looks and give me a decimal point. So who grabbed their calculator? You're helping us out with that today. I know I'm going to tell you it's negative. -240. All right, so now we've got to identify the absolute max. I'm going to do min first. Absolute min, absolute max. Absolute max. Okay, so which number is the smallest? Is it -5 the smallest? So my absolute min is at -1, -5. Where's your absolute max? What's the biggest number? 0. So 0, 0. But you see how this time one of the endpoints was the min? So it's really critical to make sure you check the endpoints, okay, when we're doing absolute. And we only do it when we're doing absolutes. Okay? I'm waiting.
Why is the x 0
For the absolute max, because look at the numbers we had. We had a 0, a -1, a -5, and a -0.2. Which one of those is the biggest number?
0. But I thought that it would go into the 1, not the x. Why did you put 0 in the x?
In the x spot, because it was 0 in for the x, 0 in for the y. Okay? All right, we good? Everybody on 2? All right. So Let's take a look at this one. The way this question is worded is a little bit strange. So look at all the answers are all the same. It's just it's an open versus and a closed, right? So that's going to change it a little bit. So let's first of all start by finding our critical point and seeing what our critical point was. So how do we get the critical points, guys?
Plug in the
Not yet.
derivative.
Derivative. So I'm going to take the derivative before I try those intervals, okay? So when I take the derivative of f of x, what do we get? -1. Is the derivative in any of the intervals? No. So I'm not even worried about it because it's not a critical point on the interval, okay? So we're going to go ahead and just plug in the endpoints. So this one here, both endpoints are valid because it's closed. So I'm going to plug in f of 1 and f of 4. And we're plugging into this 5 minus x. So what is 5 minus 1? 4. And what is 5 minus 4? 1. So which one is the max? And which one is the min? This one, f of 4 is the max, right? So absolute max is 1, 4. Absolute min would have to be the other one, right? 4, 1, because the y value is smaller. All right, looking at B, the only closed part is the 1, right? So I would say, I already know that f of 1 equals 4, don't I? Didn't I already calculate that? And would that be the max or the min? What did we say about it? It's the max. So we would say that the max in that interval would be 1, 4. What about in C? If we look at an interval like C, which one is the only valid point? The 4. So I already know that calculated that f of 4 is 1. Was it a max or a min? So there's a min at 4, 1. What about on D? Neither. We don't have any extrema in that interval, so we'd say no extrema. No, you don't put does not exist. I guess you could, but... All right. Last one, we get to sketch a graph. We haven't done that in a while. All right. So notice it's a piecewise function. That means that there's two branches or a couple branches to it. We have to graph in between these values, okay? And then we're supposed to locate the extreme of the function over the given interval, okay? So the first thing I'm going to do, I'm going to change to, what color am I in? I'm in purple, that's not going to show. Let's get red out, because red's going to show better on that graph. Okay, so let's talk about what kind of a function this is. What kind of a picture is a squared? Parabola, right? And its vertex point is probably up at 2, isn't it? All right. I am going to... This isn't going to... Oh, this is a horrible, horrible graph. My y-axis is in a really bad spot, okay? So we're going to pretend that that's not my y-axis right there, okay? I'm going to cross out my y-axis. I'm whiting it out. Isn't that nice? Digital whiteout. Okay. So I'm going to redraw my that's the x-axis, not the y-axis. I'm going to draw it up here. Huh? I want to move it up. It needs to be moved up a little bit, okay? All right. So there's your x-axis. This is your y-axis. It needs some space underneath. It's a bad, bad picture, okay? All right, so I already said that my vertex point is at 2, but here's the thing. Do I start graphing at 0? I don't graph until 1, right? So I could calculate what that actually is. When I put a 1 into this function, you're listening, putting a 1 into that function, what's 2 minus 1? 1. So my first point of that parabola is at 1. I could plug this endpoint in there to find out kind of where it ends. All right, so I actually really don't need that first red dot, do I? All right. Then the endpoint of that, other endpoint of that parabola, I plug a 3 in. If we get 2 minus 9, what do we get? -7. So I'm going to take at 3, I'm going to go down -7. So 1, 2, 3, 4, 5, 6, 7. And we want to kind of make it curved like a parabola, right? So why did I draw it with an open circle?
Because it doesn't have
No equal to. Good. All right. What's this a picture of? a line, right? Okay, now I could go ahead and just sketch the line, or could I plug in my values again? Yeah, let's plug it. Probably plugging in the values is going to be easier. So when I plug a 3 into it, I get 2 minus 9, which is what? -7. So isn't it at the same place? But I now get to close in the circle with the blue. All right, and then we're going to put in the 5. What is 2 minus 15? -13, which I don't think ends up on my graph, does it? Let's see, 7, we're at 5, 8, 9, 10, 11, 12, 13. It's somewhere down there. I didn't make my axis up high enough, did I? All right, so there is a picture of my function. And again, we did all of this by plugging numbers in. We need to identify our absolute extrema. So where is our absolute max?
Right there at 1.
At x equals 1, but we know the point is 1, 1, isn't it?
Yeah.
All right, our absolute min is where? -5, and we said it was, I'm sorry, not -5, +5, -13. What's the highest point? What's the lowest point? That's all we're looking for. Okay? No, because it's a point. And see, do you see why we now switch this to represent the point? Because we use interval notation with the brackets and the parentheses. So that's why they switched to that. All right, that's it. I believe I split the homework assignment into 3. So that way you get 3 sets of homework points for it. It's